Okay, so hi, I'm Mark Rendle. I'm currently calling myself the CTO of Visual Recode, which is a product I've been working on to help people move from .NET 4 to .NET Core. And this talk is .NET is dead, long live .NET, which is quite a bold statement, but hopefully I will have explained it well by the end of this 50 minutes. This is my first kind of conference talk. I've done a user group talk online, but I'm still kind of getting used to it, so please bear with me if I have a few technical issues. And I'm just going to assume you're laughing at my jokes because I won't be able to hear you. So here we have the timeline of .NET, starting way back in 2002 with .NET Framework 1, and then we had kind of 15 years of good solid development and iteration on the .NET Framework. And then at around that time, somebody at Microsoft went, let's just throw the whole thing away, burn it to the ground, and start again from scratch, open source, developed in the open on GitHub. Cross-platform, we're going to support Linux, we're going to support Mac, we're going to support everything. And then now at the point where we've got to .NET Core 3.1, which is the current long-term support version, and this November we'll be getting not .NET Core 4 because they decided that would be too confusing. So we're getting .NET 5. They are finally saying, okay, this is the next version of .NET after .NET Core 3.1 and also after .NET 4. So we're recombining everything back together into one framework, and that's where the development is going to be as we move forwards, which is great and fantastic and lovely. And so these are the frameworks over the lifetime of the original .NET framework, .NET Classic, let's call it. It started out, it came with Windows Forms and ASPNET Web Forms. Windows Forms was basically Visual Basic, but in C#. And ASPNET Web Forms was a way for people to build web applications while pretending they weren't building web applications. And then in 3.0, at the same sort of time as Vista came out, we got Windows Presentation Foundation and Communication Foundation and Workflow, which was originally called Windows Workflow Foundation, but then the World Wildlife Fund complained about it and they had to rename it. Of course, along the way, we had Silverlight. I would normally at this point say hands up if you miss Silverlight, and 3 or 4 hands would go up. But we can't do that. And then we had ASP.NET MVC, which was famously written by Scott Guthrie on a transatlantic flight, and ASP.NET Web API. And so these were the frameworks that we built all our applications with on the .NET framework for many, many years. And then we get .NET 5 comes along. And this was announced last year at Build 2019. Back when people could actually get on planes and fly to places and meet each other and drink beer, and oh, it was great. And Scott Hunter and various people went, okay, the future of .NET is .NET 5, and this is where all the development is going to be from now on. And .NET 5 is going to look like this. So we have, for desktop, you have WPF and Windows Forms, which are both supported already in .NET Core 3.1, and you have UWP, which is for building applications for Windows 10. And for the web, you have ASP.NET Core, with all the millions of frameworks that that's got inside it. Azure is a first-class way of running your .NET 5 applications, but so is Google Cloud, so is AWS, so is everything else. The Xamarin tools for building mobile applications. I don't know what Unity being there means. I don't know if Microsoft are intending to acquire them or what's going on there, but Unity is for building cross-platform games using C# and .NET. You can run .NET Core on ARM devices. If you understand machine learning and deep learning, which I don't, but apparently if you do, you can use ML.NET and .NET for Apache. And all of this combines into one .NET 5 platform. It's all developed together. Mono's part of it, Core is part of it, and this is where we are going to be writing our applications from now on. So looking back to those old .NET frameworks, we can see that several of them haven't made the cut. So we've got Windows Forms and we've got Windows Presentation Foundation. Those have made it over to .NET Core 3.1 and they'll be in .NET 5, but only when you're running on Windows. So you still can't create a cross-platform application with Windows Forms or Windows Presentation Foundation. ASP.NET Web Forms that's gone, it's dead, we're not doing it anymore. View state was such a bad idea that we can't possibly carry on doing web forms. Windows Communication Foundation, similar sort of thing. WCF was great for building SOAP services so that Java clients could talk to your .NET server, but we're not doing that anymore. No one does SOAP anymore. It's all moved on, and we're doing different things. Windows Workflow, Silverlight, obviously. ASP.NET MVC, there's ASP.NET Core MVC, but they're quite different. So you might be able to bring quite a lot of your code across, but at the same time, quite a lot of it is going to need some fairly serious rework. And ASP.NET Web API, that actually is quite easy to migrate over to ASP.NET Core MVC. ASP.NET Core MVC has removed the distinction between an MVC application with views and an API application that just returns data objects formatted as you want them. And so what I want to focus on in this talk is how you migrate, how can we get ourselves from the applications that we've invested 15 years in building in things like web forms or WPF or WCF, how can we take those and bring them into the modern world, migrate them to .NET Core 3.1 or straight to .NET 5, which is, I think they just released preview 2 of .NET 5. So Microsoft's recommendations for migrating these platforms across, if you have an ASP.NET Web Forms application, then the closest equivalent to that in .NET 5 is the new Blazor framework. For WCF applications, Microsoft have explicitly said we recommend migrating to ASP.NET Core GRPC. For people with Workflow Foundation, there is actually an open source port of the Workflow Foundation code base that you can use. There's an open source port of WCF as well, but it's still very early stages and there doesn't seem to be a lot of enthusiasm around developing it. Silverlight, not only is Blazor the replacement for Silverlight, I believe I saw a project where somebody was implementing the Silverlight runtime in Blazor so you could carry on running your Silverlight applications, which sounds interesting. I won't be looking at that. WPF and Windows Forms, Microsoft would really, really like it if everybody migrated to UWP, but they've been struggling to get take up for that idea. So they're kind of mixing UWP into WPF with XAML islands now. That all works very well, but it works very well if everybody out there is using Windows 10. If you've got some places that are using Windows 8 or 8.1, or as is more likely now, a mixture of Windows, Mac, and maybe even Linux desktops, then you're still stuck in a single platform world with Microsoft's solution for that. So let's start off. We'll look at this ASP.NET Web Forms to Blazor and talk about how we might manage that. And it's very difficult to do a port from Web Forms to Blazor. It's basically, okay, freeze development on your old application and recreate it from scratch in Blazor, which is still very new, and deal with all the differences between those platforms. So ASP.NET Web Forms, you had ASPX pages with code behind, and it would generally do round trips and trigger the page load event with event handlers, and it only runs on .NET 4.5 or 4.7 or whatever is the current .NET 4 version. Blazor, meanwhile, we now have Razor components. It deals with code behind using partial classes. It handles interactivity with either WebSockets in the server-side model or WebAssembly, which is in preview at the moment, but will be fully available in .NET 5. And Blazor runs in .NET 5 or .NET Core 3.1 and .NET 5 only. So you can't do a phased migration of the application. And one of the things that would make this path much easier is if we could say, okay, let's do a page at a time, or a component at a time, or even just a control at a time, and migrate that across. And we can do a gradual migration as we're maintaining and enhancing and building on the application. And so with that in mind, I've been doing a lot of research around this over the last year or so, and I found a framework called .VVM, which is very interesting. So .VVM, if Web Forms was an attempt to make building a web application feel like you were building a Windows Forms application, then .VVM feels like an attempt to make building a web application feel like building a WPF application. So the view model idea. And so it has this view model architecture, but the key thing with .VVM is that it runs on .NET Core. So I have got it running on .NET Core 3.1, and it runs on ASP.NET 4.5. So this means that you can carry on maintaining your ASP.NET Web Forms application, and you can do a gradual migration from ASPX pages and code behind and the .NET 4.5 code to .VVM. And eventually, once you get to the point where you've migrated all your pages and your controls and functionality and everything across, then you can just take that .VVM application, and it's a very quick job to dump all your views and view models and everything into a .NET Core or a .NET 5 application, and you're off and running in the new world. So let's take a quick look at some .VVM code, which I have prepared earlier. So here I have an application, and if I just run this quickly, so this application is currently just using are you running? Yeah, there we go. So this is a pure ASP.NET Web Forms application, which is slowly starting up. Very slowly starting up. Come on, what are you doing? I'm going to find out where it's gone. There it is. It takes it a while. So there we go. We have our application, which is showing a list of .NET frameworks, and then I can click on one of these and it will take me to an information page about that framework. So this is using the latest ASP.NET Web Forms running on .NET 4.7.2. And yeah, it's a basic, straightforward two-page application. Now with .VVM, I can gradually replace pages in the ASP.NET application. So let's take a look at the framework info page first. move that across onto here. And then we'll take a look at frameworkinfo.aspx. And so you can see here that I've got just very, very simple code with ASP labels. Just going to put in some line breaks here so that people can see these things slightly more easily. So yes, we have so ASP content and ASP labels to set things, and an H1, but then because I want this to be data represented, I have an ASP label with the class set to H2, and it's a standard ASPX page, and it's using a master page file at site.master that you can see here. And then on the other side, I have my frameworkinfo.html, which is a weird extension to have, but that's what he's gone with. And .vvm files are divided into views and view models. We don't have any controllers here. It's similar to Razor Pages if you've used Razor Pages in .NET Core, but mixed in. So we still have the concept of a master page, except this is now a .master, and we have a lot of the same tags and attributes as in ASP.NET, and that's obviously a deliberate design choice by the creators of this platform, except instead of ASPNet, you have ASP:, you have DOT:. And unlike ASP, where for things to be rendered, they have to be controls, .vvm does actually support inline binding with these handlebars or moustaches, where you say value : framework name, and this is binding directly to a view model, and the view model is quite similar to the code behind for an ASPX page. So we have it actually derives from a view model, and this is a base view model for the entire site, which declares some properties that are needed on all pages, so the current year and the title of the page, and that derives from .vvm view model base, and that provides virtual methods that we can overload, like load, and there's a pre-render and there's an init, very similar life cycle to ASP.NET pages. But this then just has properties, and those properties are bound to from the code here. So we can see we have framework name, framework version, framework year, and so those are in the view model. And then over here we have a .vvm startup. So we're using owin to hook this up, and that's nice and easy. So we have our owin startup class here, and our owin startup just says app.use.vvm startup. And that .vvm startup is where we can configure routes. And in here, we can actually, if you add a route in here, this will take priority over the ASPX page. And if you leave, you can put in sort of anything you want to in this second argument here, which is the URL. And this supports a lot of the same bindings and everything else that Razor routing supports. So you can put templates in here with braces to specify parameters for the page. If your site currently uses .aspx for all its page extensions, you can actually put .aspx on the end, and it will still overwrite that, but I don't want to do that. And so now, when I go back into my site and run this again, which hopefully will take less time this time, we shall see. So default.aspx will still be the ASPX page, but framework will now become my framework.html page provided by the .vvm runtime. What is my machine doing? I keep telling my wife I need a new PC. So, localhost default. So I didn't make any change at all to the ASPX page. So this is still redirecting to framework info !, slug equals Windows Forms. But you can see it's a bit slow the first time it loads each of these pages because it has to do an internal compilation. So it's useful to do a warm-up phase, but you can see here that this is now saying my .vvm application here. So this is coming from the .vvm runtime. And then if I add in the default page as well, then all my ASPX pages are gone. And you can see here that the default, slightly more complicated. So it's using the grid view, which generates an HTML table styled with the Bootstrap classes for that. And then we have a column section, which has a bound field and a hyperlink field. And .html provides a dot::grid view. Data source binds to a value on its view model. Class is still basically the same. We have a grid view text column, and it doesn't have as many different kinds of fields that you can put into columns directly, but it does have this grid view template column, which again, similar to WPF, allows you to put whatever you want in the content template. And so here I'm using another feature of .vvm, which is the root link, which is very nice and allows me to specify paths in my application as long as they are part of the .vvm root table. So I can just say the root name is framework info, the text for the link to display, and then query-slug will set the slug element on that query string. And so now if I run this, and we'll wait for this to go through again. So now I have completely removed all the ASPX pages from my application. Everything is now running in .vvm. And so I can take the code out of this. I can take the view models and the views folder and obviously any other code that's necessary to make the thing work. Put this into a .NET Core 3.1 application or a .NET 5 application, and we are up and running. We have our gradually migrated application. Running in .NET Core. This is still running in ASP.NET 4.7 with OWin at the moment. I'm not going to demo running it in .NET Core, just trust me, it works. Grid still has the same features. We can make columns sortable. We can link through here. And then once we have gone to that page once, it's very, very quick to load up subsequent times. So that gives us the best of both worlds. We can continue to maintain and run our application in ASP.NET, running on Windows, running in IIS, using all the ASP.NET pipeline. But over time, as we're just maintaining the application, responding to user requests, adding enhancements, adding new features, we can migrate our ASPX pages to .vvm pages. And once everything has migrated across, then we can move the whole application over to .NET 5. So the .vvm framework is open source. You can go to .vvm.com, open source MVVM framework for ASP.NET Core and OWin. All the source code for .vvm is on GitHub, so you can fork it, you can modify it, you can send them pull requests. They support the project by offering various commercial packages. I'm not affiliated with this at all, but there's the .vvm business pack. So the big issue for a lot of people is going to be that there are infragistics packs or component one packs that you've been using in your ASP.NET application, and that makes it even more difficult to transition across where those packs aren't available. So the .vvm business pack provides a lot of the types of controls that you would get in those more complicated ASP.NET control frameworks. So grid views and data pages and list views, tree views, various other sorts of things in there. So that again is a way to help move across from your big complicated web forms application to .NET Core. Quite reasonably priced, $199 to get that pack. Okay. The source code for that and for the other demos in this talk is online at github.com/rendlelabs/fwdays2020. So the .vvm solution is in there with both the ASPX code and the .vvm pages for you to download and play with. And .vvm itself has an awful lot of samples and shows how to migrate from one platform to the other. So next, let's talk about desktop, because desktop actually is quite well represented. It is reasonably straightforward to take a WPF application and rebuild it as a .NET Core 3.1 application, or to take a Windows Forms application and migrate that to .NET Core 3.1. So those will work quite happily in .NET 5, but they're still Windows only. There's also UWP, which has a weird relationship with .NET. It's like, is it .NET? Is it not? Nobody seems to know whether it's .NET or not, but it's quite .NET-y. It's got a lot of XAML in it, so that's quite .NET-y. But there are a couple of other options that I thought were worth looking at. There's Avalonia, which is cross-platform. So Avalonia uses XAML, but has a completely new runtime, has been built from the ground up on .NET Core, and you can build your Avalonia application and run it on Windows or Mac or Linux. So that's interesting, and that's worth looking at. And there's also Uno platform. And well, let's talk a little bit more about Uno platform, because it is complicated. So Uno platform is fundamentally, it's UWP. So it lets you write UWP applications, but then it provides a cross compiler, so you can use the views and everything that you've declared for the UWP application. You can build iOS applications, you can build Android applications, and you can build WebAssembly applications. And being able to build WebAssembly applications means you can run them in the browser, and you can also run them in Electron. And then running them in Electron means that they can run on Mac OS and Linux, and also on Windows earlier than version 10. So this is really interesting, because UWP is Microsoft's most modern, most up-to-date desktop development platform. It's getting all the love, it's getting all the control libraries and everything else. And you also, if what you want to create is Windows and iOS and Android, then Xamarin Forms will also target UWP. So there are lots of different ways of coming at this. But right now, at this point in time, if you want to build an application that runs on Mac OS and that runs on Linux and all these other platforms, there's no officially supported Microsoft way of doing that. But Uno platform, it's actually very mature now. It's made a lot of progress. It's got really amazing support. And so I thought it would be good to have a look at this as well and see just how well it works. So let's jump into some Uno code. So I'm going to close that one down, and we will take a look at some Uno code. So here we can see that I have got my Uno application, and most of the stuff in an Uno application goes into this demo app.shared. So in here, we've got our main page.xaml, and you can see here that this is just a standard. Why are you asking to do that? Go on then. Standard UWP style XAML code. So we don't have data context. So we're binding to a view model property that is actually on the code behind for this page. So there's my view model. I'm going to remove that breakpoint because I don't want it. And I've got a framework class here, and I've got a Boolean to visibility converter, just like in WPF or UWP. And I have a demo app.droid, which is a Xamarin project that runs on Android, a demo app.ios, which is a Xamarin project that targets iPhone, a UWP, which is a Universal Windows app, and then down the bottom here I have this demo app.wasm, which is actually a NetStandard 2 library. So if I set the startup project to the UWP application and press F5, and we'll see if the demo gods are smiling on me. I've been having quite a lot of, no, they're not. Oh, right, so you actually don't have that type now. So that's interesting. This is fun because the correct way to do Boolean to visibility converter in UWP is actually to cast to visibility from Boolean. UWP's bind syntax actually understands what you're doing there and will just run that cast for you. So that's interesting. And now we have to wait while my Windows 10 PC spins up a Windows 10 emulator, because reasons. And so you can see here that I've got an unhandled exception, and I don't know why that's happening, and I'm just going to stop. That was working literally half an hour ago. But I'm going to assume most people have seen a UWP application. So we can then set our startup project to WASM, to WebAssembly, and we can go back into our main page and undo those changes, because when you're working with WebAssembly, it does not understand that casting trick that I just did. And then if I press F5, this will go through a different build process. And it will ahead of time compile this application as WebAssembly, which can then be loaded into a browser. It takes a while because it's running through about half a dozen different compilers. And so you can see here, we've got a .NET hosting environment. This is just running as a standard ASPNET application. And then here we have our UWP application running inside the browser. So I've taken a desktop application built using desktop technology, run it through platform, Uno Platform's WASM compiler, and it's running in the browser. Obviously, multiple ways to distribute this. You could do it as a progressive web application, so provide an install button. Generally don't want to be downloading 2 megabytes of WASM every time you visit a web page. Or you can bundle it up into an Electron application, or possibly I saw Steve Sanderson, the Blazor guy, has been working on a very lightweight .NET Core WebView wrapper that you can just compile straight into the application. And so it would be interesting to look at whether that could be combined with this to provide a lighter weight environment than Electron. But again, we have a way of doing a phased migration. So obviously, you know, if you're working in a big enterprise and you've got a WPF application, nobody wants it running on Mac or Linux, then absolutely just carry on using WPF, and maybe use the new XAML Islands feature to bring in some UWP controls into that. But if you are looking for a way to take your WPF or your Windows Forms application cross-platform, then the same gradual migration approach here, you can migrate pages or controls or sections of the application to UWP, host those in the WPF or Windows Forms application using XAML Islands, and then once everything's migrated to UWP, you've got that as an application target, and then you can import that into a Uno platform project. And I'm not saying you're just going to be able to build it as WebAssembly. For example, don't use Listbox because WASM doesn't like it for some reason. It is still a work in progress, but go to UWP and you get to a place where you have a lot more options for moving into other platforms or for deploying onto iOS. You know, these days when Apple have finally admitted that a massive tablet with a huge keyboard with a trackpad and a cursor is actually quite a good idea, and they're really glad they thought of it, then the ability to build your UWP application, your Windows desktop application for iOS could potentially come in quite useful. Okay, again, the Uno demo code is on GitHub, same URL as the last one, for you to download and take a look at. And I will try and fix those problems with it and do a push sometime later today. Okay, finally, Microsoft's recommendation for WCF was to migrate to gRPC. And this is probably the biggest, you're gonna have to throw it away and just start again area of all of this. So WCF launched back in 2006 with Windows Vista, was supposed to be built into Windows Vista, but then became part of .NET 3.0. And WCF's big thing was you could interop with other systems because it talked SOAP over HTTP. And so it was, it played well in multi-platform enterprises and environments like that. It also had an incredible high performance mode called NetTCP, which allowed you to do lots of very, very clever things, but only worked for .NET to .NET. So that was slightly less useful. And of course, it had, everything was configured. You chose what transport you wanted and what security you wanted. Everything was configured in XML. And if you've ever had to maintain the web.config file from a medium to large size WCF application, then you have my sympathy. Now Microsoft are saying we should go to gRPC. And if you don't know what gRPC is, it's a remote procedure call framework based on protobuf. So it's based on it in two ways. It uses it as the over-the-wire format for serialization of messages, and it also uses it as the language for declaring your messages and services. So protobuf is language neutral, platform neutral. It's easy to extend. It's very small, it's very fast. It doesn't use a lot of CPU or memory to do the serialization, and it's reasonably simple. Certainly compared to SOAP, it's very simple. gRPC just builds remote procedure calls on top of protobuf, and that means that you have gRPC runs over HTTP2, and it's cross-platform. So the binary format of protobuf means that you get NetTCP style performance, and they are very, very close. NetTCP may be slightly faster under some circumstances. gRPC is pretty much as fast and uses a lot less memory. But gRPC also provides the same level of cross-platform interop that SOAP used to give us, even though back in the days of SOAP there were only 3 platforms, and now there are over a dozen. gRPC supports all of these. The first two columns down to PHP have officially supported gRPC compilers. Perl, Rust, Haskell, Scala, Kotlin, Elixir, and Erlang all provide community-provided compilers. And gRPC, the one downside to gRPC is that you can't use it from the browser because it uses HTTP2, and it uses features of HTTP2 that browsers don't support, like trailers. Trailers are like headers, except they go after the content instead of before it, and browsers don't support trailers. gRPC uses them, so it can't run natively in the browser, even though it can run in JavaScript because it's available in Node.js. To get around that, there is a thing called gRPC Web, which is actually a proxy server that you run next to your gRPC service, and then your web application connects to the proxy, and the proxy connects to the gRPC service, which is great, and it means that you can write the service once and just access it through the proxy, but it does involve deploying two services. James Newton King of JSON.NET fame, who is now working on the gRPC framework for Microsoft, has actually got an experiment that he's put up. You can go to that link, devblogs.microsoft.com, where he has built the gRPC proxy into ASPNET Core as middleware. So within a single application, you can deploy your gRPC service, and you can deploy a gRPC web compatible version of it, all running in the same process, just running on different ports, all going over Kestrel. Still an experiment at the moment, not clear what's going to happen there. But yeah, so migrating from WCF to .NET Core is not particularly straightforward, but I have an example here. So I have a hotel application here, and we can see that this is a WCF application. I have a hotel service with get available rooms, which returns a list of rooms, get a single room by the number, which returns the room, get an array of rooms passing an array of numbers, and an IEnumerable of rooms to get all the rooms in the hotel, all 237 of them. And this is using data contract. So WCF, we have data contracts, we have data members, we have service contracts and operation contracts. We have code that implements our interface that will become our actual service. And we have a dependency, room data, which is set up here, that is used to actually talk to a database, or in this case, just return an array of rooms. So that's our WCF application. The equivalent gRPC application looks reasonably similar. We now have a so this is a solution that's been converted using my Visual Recode tool. So it's copied as much of the code as possible over, and then it's wrapped it, it's analyzed the interfaces and data contracts and everything of the original, and generated the necessary protobuf code. So here you can see, excuse me, my throat's drying out. We have a hotel service, so a gRPC service maps to our WCF interface, and we have requests. So that's a slight difference. gRPC methods can only take a single message as a parameter, and they can only return a message as a response. So for like lists of things, we have repeated values in here. For the all rooms that was returning an IEnumerable, this returns a stream, which is a streaming response. and we have some code here to convert from the built-in hotel data room class, which was our data contract, to the protobuf generated type, because protobuf generates stub classes for the services and the messages. And here we have a hotel service. This implements the gRPC base class that's generated by the compiler, and this has been done so that it just injects the service contract from the old WCF application and just maps the calls across. So it just gets the WCF code into a .NET Core 3 application and gets it running. Again, it's not so. This will be in the GitHub repository, although I haven't actually pushed this up there just yet. But this is in a .NET Core 3.1 application. And you can do this migration manually. It depends how complicated your application is. If it's not particularly big, if you've got like half a dozen endpoints, then it's easy enough to do manually. If you've got 1,000 service contracts and 10,000 data contracts, then it's the sort of thing you could look at automating. Like I say, the demo code for that will be up at my GitHub repo, Fwdays 2020. I also co-authored a book for Microsoft on gRPC for WCF developers, which talks about all the features of gRPC from the perspective of WCF and how to approach that migration, and the various different patterns and everything else. That's free online in PDF format at the Microsoft architecture site on docs.microsoft.com. So I'd like to finish up by talking about some general migration strategies just for a couple of minutes, ways to get from .NET 4 to .NET 5 without breaking the world along the way. And some of it is things that you can do in advance. So while you're still working in .NET 4, whether it be ASPNET or WCF or WPF, whatever it might be, start to think about re-architecting your code. So if you pull code that is maybe sitting inside a Web Forms project or a WCF project, try and extract as much code as you can into new SDK style class libraries. So the ones that match the .NET Core project CS Proj style. And if you can get those libraries to dual target Net 4.7.2 so that they carry on working with your old application, and Net Standard 2.1 so that you know they will work in the new applications, then you can do a lot of this work up front and make life easier when you come to make a final jump. You can extract components to standalone services. So data access, for example, if you're going to go from Web Forms to Blazor or from Web Forms to .VVM, then you're going to want to be able to write a client-side browser application that can talk to a service to do things like database queries. You do not want to be sending raw SQL queries over HTML, and other services that are potentially just sitting there in a folder in your Web Forms application, like mail or file system access or whatever it might be. And review your third-party components. Look at whether you're using Infragistics or Component One or DevExpress or any of the others, because you don't know how many of those are going to be available. If you are with a particular vendor, check to see whether that vendor supports the new platform that you're migrating to, and how easy it's going to be to migrate the code from the old style to the new style. If they're not, then decide whether you actually need those components or whether you can manage without them. Prior to migration, make sure all your NuGet packages are up to date and have .NET standard versions. Do not be using things like SQL Server CE.dll, which is not supported in .NET Core. If you've got a lot of references to framework-specific stuff like ASP.NET static server class or WCF's operation context dotted throughout your code, do what you can to remove that. It'll make it easier to move things across later. Just clean up your code, remove all that commented out stuff, reorganize it, work it into class libraries, make it easier to understand, make it easier to maintain. Go async. If you're still using SQL connection.open and SQL connection.execute, change to the async versions of those, which will be much more at home in .NET Core. During the transition, you can create client shims. So for gRPC, you can create a wrapper around the gRPC client that matches the signature of the WCF client. And so you can help the other teams who are consuming your services transition like that. And you could also create service shims. So you might, if you're going from WCF to gRPC, you might create a version of the WCF application that just proxies to the gRPC service, similar to gRPC Web. And that way you can still support all the old bindings and wait and give people a stepped migration to gRPC or whatever your new services might be. The same for that applies to ASPNET Web API going over to ASPNET Core MVC, for example. I have to mention Visual Recode. It's how I'm attempting to make money at the moment. It will do some of this stuff for you. It will do, currently available now, it will do WCF to ASPNET Core gRPC, including duplex services. Coming up soon, it will do WCF to ASPNET Core Web APIs, and then later this year, it will do Web API to ASPNET Core MVC as well. If you want to get in touch with me, you can catch me on Twitter. My website is visualrecode.com. I'm on LinkedIn at LinkedIn/Mark Rendle. That's it from me. Thank you very, very much for listening to me. I hope that was helpful, and I will be hanging around in the after party if anyone wants to say hi or ask any questions.